Hello everybody and welcome back to another video by Fundan Tutorials. In our last video we talked about what essentially a prisoner's dilemma is. In today's video we will be talking about how to solve a prisoner's dilemma. So if you are a little confused about what prisoner's dilemma is, or if you have forgotten, or if you don't know, this is your new video that you're watching, I highly suggest you to watch the introduction video on prisoner's dilemma, which will be probably linked somewhere up over here on the top right corner of the screen. Coming back to the solution of the prisoner's dilemma, what are we looking for? Let's find out first. So essentially what we want to find out is what will the two prisoners end up doing. So what do they want to do? Now here each prisoner has two options to make. Either they can confess to the crime that they have committed, or they can deny to the crime that they supposedly have committed, which the policeman supposes that they have done. Now the way we will be solving this is we will fix one action for each player, and we are trying to find out what happens if he or she makes that action. Suppose I say that the player 1 confesses to his or her crime. If the player 2, if player 1 confesses, so I fix this row. Let me just highlight that so that it's easier for us to understand. Suppose I am now the second player, and somehow I have a premonition, or I guess that player 1 is going to confess. Suppose player 1 is one of my best friends, and I know my best friend for a long period of time, and I know that even if we do make some wrong moves here and there, my partner in crime, player 1, that is prisoner 1, is in general a good person at heart, and I feel that player 1 will confess at the end of the day, no matter what anybody else does. If as player 2 I feel that player 1 will probably confess, then let's see what I should do. Suppose this entire analysis is based on the fact that suppose player 1 confesses. If player 1 confesses and I confess as player 2, I get a payoff of -6, right? So if player 1 confesses, which I have assumed, and I decide to confess, then as player 2, since I said in the previous video, I will be assuming that the first numbers represent the player 1's payoff. Payoff here means what I get out of a decision, and player 2's payoff, or what I get out of this, what player 2 gets out of his or her own decision, that is player 2's decision, is represented by the second number. Player 2 sees if I assume that player 1 confesses and player 2 confesses even after player 1 confesses, then player 2 will get a payoff of -6. However, if player 1 confesses and player 2 somehow still denies of the crime that they have supposedly committed, then player 2 will again look at the second payoff and he ends up with -9. So if player 1 confesses and player 2 confesses, he gets -6. But if player 1 confesses and player 2 denies, then he gets a payoff of -9. Now let me compare. Suppose player 1 confesses, and now I want to find out whether given that player 1 confesses, should I confess or should I deny? As player 2, should I confess or should I deny? I know that -6 is greater than -9, right? Losing 6 years of my life is better than losing 9 years of my life. So if player 1 actually ends up confessing, I am better off if I confess. So let me just mark that like this. I will confess. If player 1 does confess at the end of the day, as player 2, I think I'll be better off if I confess. At least I'm saving 3 years of my life that way, right? So that is based on the assumption that player 1 confesses. Now let me think of it in the other way. Now let me think, what will I do if player 1 denies? That's also a possibility, right? So if player 1 denies, suppose I second guess myself and I say, no, I am not sure. Maybe my best friend player 1 might actually deny. Maybe, I don't know. So suppose I take that under consideration as well, and I say, what happens if he or she denies? What do I do then? So if player 1 denies, let me again go by the same approach. If player 1 denies, and I end up confessing, I get 0, right? Okay, yeah, because the other person denies, but I am being truthful, and the policeman likes me if I am being truthful, and I get away without any punishment. So if the other player, if my best friend denies, but I end up confessing, I am actually better off in the, the most better off, the best off actually, because I have confessed and I get away without any punishment and I get a 0 payoff out of it. However, if the other person denies, that is if player 1 denies, and if I as prisoner 2 also deny, I get a -1 payoff. So now I am looking at a comparison between a 0 payoff and a -1 payoff. Given that prisoner 1 is actually denying, again it's an assumption for me as a prisoner 2, if prisoner 1 actually denies, I get payoff of 0. Again, payoff is the situation or the outcome that I see, or the result that I get when I make a decision. So if my decision is to confess, given that my friend is actually denying, I get a 0 payoff. So I do not lose or gain any years of my life. But if my friend denies and I also end up denying, I actually lose just 1 year of my life, which is pretty good compared to the fact that I was losing 6 or 9 years of my life in the other cases. But 0 is still better than -1, right? I am not losing any life here, but here I'm still maybe spending 1 year of my life in jail. I still feel that confessing is better, right? So whether my friend confesses, if my friend confesses, I also confess. But even if my friend denies, I am still better off if I confess, because 0 is better than -1. So is -6 better than 9, but 0 is still better than -1. So you realize whatever player 1 does, I am always better off if I confess, no matter what. Even if my friend confesses or denies, I compare one with the other and I find out that I'm actually better off compared to when I deny. So suppose whatever the other player does, I am better off confessing than I would be if I were to deny, in whatever situation, in whatever decision my friend takes. This sort of decision, the fact that it's always better if I make this decision, these sort of decisions are called strictly dominating strategies. It's sort of a strategy, right? If he does this, what should I do? If she does this, what should I do? If she doesn't do this, what should I do? It's sort of a strategy. And these are called strictly dominating strategies, because you are always better off if you make this decision. It's strictly dominating the other strategies. So confess is here a strictly dominated strategy, and deny is a strictly dominated. So confess is dominating strategy, the one which dominates, and deny is a dominated strategy. So let me just write that down. Confess here is a dominating strategy, and deny is a dominated strategy. This is the one which is dominating, the better one, the one which always is superior, and deny is a dominated strategy. Similarly, if I now look what the player 2 thinks is, okay, fine, cool. If player 1 decides to confess or deny, I don't care. I'm always better off confessing. So might as well confess. I don't care what the other person does. Now let me look at player 1's decision. If player 1 thinks of it the same way, then player 1 will have to, let's see, if player 2 confesses and I as player 1 confess, I end up with a payoff of -6. Whereas if my friend confesses and I deny, I end up with a payoff of -9. Note that here, since I'm talking about the first player, I'm looking at the first numbers. So comparing -6 and -9, again, I'm better off with -6, right? I'm still losing less compared to losing more. Losing less is better than losing more, at least. So I end up choosing confess over deny if my friend confesses. Now what happens if my friend denies? So this time I'm looking at this column. This time I'm looking actually column wise. So this was one column, the one where I chose confess, and now I'm going to choose suppose my friend denies. I don't know, he or she might have a premonition that I might be doing something else and they end up denying. So if the other person denies and I confess, I get 0 payoff. But if the other person denies and I deny as well, I get -1 payoff. I'm still better off if I confess. I'm getting a 0 payoff compared to a -1 payoff if I deny, which means I actually end up choosing confess even here. Again, you realize whatever the player 2 does, confess is a dominating strategy for player 1. So here too, confess is a dominating strategy. So let me just write that down without covering anything. Let me just shift that this side. And deny, again for this case too, is a dominated strategy. So what happens is, usually by this logic, players should play a dominating strategy, right? They're better off irrespective of whatever happens, whatever is decided by the other player. So actually, at the end of the day, both players end up confessing. This is essentially the prisoner's dilemma. Now you might be asking, okay, fine, both the players are confessing, that's good because they are confessing to their wrong misdoings, and prisoners get some sort of jail time, and it's still better off than getting -9 payoff, and the policeman is also happy because the prisoners are owning up to their mistakes. Where is the dilemma? The dilemma is, you see, -6 is the outcome. It's called a Nash Equilibrium. We might discuss later why it's called a Nash Equilibrium. Essentially, it's related to a person named John Nash. Why did the equilibrium come here? Okay, let me just shift it here. It's sort of the research work of a person named John Nash who discovered this sort of equilibrium. We'll be discussing about Nash Equilibrium in a future video. The dilemma is that in this supposedly Nash Equilibrium, where the two prisoners confess, they get a -6 payoff. But there's actually a better situation as a society which could have been achieved if they both were trusting of each other and they both denied. Here, these two people are actually suffering from 6 years jail time, but this is just 1 year jail time for both. This is actually a better payoff for both of the players. But why don't they do it? Because suppose somehow they, I don't know, maybe they are good at telepathy and they say, okay, please deny and I'll also deny, so that way we are both better off. If player 1 is a very truthful person, even if player 1 is a very truthful person and player 1 sticks to denying, player 2, so player 2 means the second number, player 2 can actually be better off if they switch to confess. Right before the case opens, the player 2, if he or she decides to switch to confess, they are actually better off from -1 to 0. So player 1, and then in that case, this entire cell will shift to this and player 1 will end up getting -9. They had decided on a -1 payoff, but player 2 ditched player 1, and what happened is player 2 became better off by getting a 0, but player 9 was pulled to an even worse situation where he is actually getting a -9 payoff. He is suffering from 9 years of imprisonment. So this is actually a pretty scary situation for both of the players. They might not trust each other and they might think, my friend can actually ditch me anyway. I don't know. They can leave me. They can stab me at my back. So this fear factor essentially forces them both to stay in the confess region, because I don't care what you do, I'm still better off. Whatever you do, I'm still better off if I confess. I know it's not the best possible situation, but I don't trust you and it's better off if I stay here. This is essentially the core or the substance of prisoner's dilemma. They could have been better off if they trusted each other, but since they are not trusting each other, this is the best that they can achieve, and this is essentially the soul and substance of prisoner's dilemma. This prisoner's dilemma is a very backbone of game theory, and it can be culminated and enhanced, evolved into more complex problems, which we'll be discussing in future videos.